Hello, everyone. Welcome back to another episode of the Cedarville Stories podcast. I'm Mark Weinstein, and I've rarely given much thought to protecting our oceans and using water as a means to serve others. My guest today, Toby Dewhurst, lives with these thoughts in his mind as he leads Kelson Marine, an offshore engineering company based in Portland, Maine. Today, we'll discuss how his faith in Jesus impacts all the work that he does. So sit back and enjoy my conversation with Toby Dewhurst on this week's Cedarville Stories podcast. Thanks for joining me this week on the Cedarville Stories podcast, Toby. It's great to meet you officially, and I'm really looking forward to learning more about what you're doing. Let's begin with mechanical engineering. Your degree, it's from Cedarville University. I know engineering runs deep in your family. Your dad, Dr. Tim Dewhurst, is a senior professor of mechanical engineering at Cedarville. So I'm curious, for starters, do you recall what sparked your interest in engineering, and then how you took that to, or where did the interest in oceans come from?
Yeah, definitely. So I came into Cedarville undecided, actually.
Okay.
You're right. My dad's an engineering professor. I think he tried pretty hard actually not to push us toward engineering, not because he didn't like it, but he wanted us to be able to choose for ourselves.
Right.
So I took my time deciding what I was going to study. But eventually decided that yes, indeed, I did like the idea of building things and designing things. I see engineering as a bit of a marriage between physics and design, and I liked both of those things.
Okay.
So that got me into mechanical engineering, and then my senior capstone, led by my dad, was a solar boat competition, and my job on that was designing hydrofoils for this boat. So like airplane wings, but underwater to actually lift the boat out of the water so it can move through the water with less drag. I pretty much failed at that. We could get them to lift, but I couldn't get them to stay stable. I think the team won overall still, but
was that for the solar boat?
What?
Was that for the solar boat competition?
Yep. Yeah, the solar boat competition.
Okay.
So that opened my eyes to just how much there was to learn about fluid structure interactions and the complexities of boats and other floating platforms interacting with waves and currents and everything.
Yeah.
So that got me interested in ocean engineering. So I decided to go to grad school to pursue that, partially because I wanted to live near the ocean and partially because I wanted to solve challenges that mattered for humanity. And then I got to grad school and they said, we have no money for anything like building fast boats, but do you want to get into tidal energy, converting the kinetic energy in tides to electricity? So I said, sure. And that started me on my journey working with sustainable energy. And my ocean engineering career went from there.
I think it had to be encouraging to have your dad as a professor who, not only does he know you academically, but he knows you personally. So he has a vested interest, and I'm sure he didn't push you any harder than he pushed anyone else, knowing your dad.
Yeah, he was really good. He was also my academic advisor. So we got to spend some time mapping out what I wanted to do in life and how to get there. So I enjoyed that. It was a new phase in our relationship, I guess.
Yeah, that's something very few students get the opportunity to do and to have. So, Toby, when people hear the phrase offshore engineering, it can feel distant, it can feel abstract. What does that mean? How do you describe what you do in the way it connects with everyday people?
Yeah. So when we talk about ocean engineering, we're talking about designing structures that go in the ocean, especially these floating arrays that are meant to do something for, in our case, producing food or energy from the ocean while withstanding the average conditions and extreme conditions in the ocean, waves, winds, currents. So our job as engineers is to take the physics of those fluid structure interactions and use them to help people design structures that perform and survive without being exorbitantly expensive.
Thank you for that. For a student from Cedarville, now leading an international company that you started, that's Kelson Marine, has anything surprised you about the journey that you've taken? Has it gone like you anticipated? What challenges have you had to overcome, and what came easy?
Yeah, good question. So I did not ever picture myself as an ocean engineer until I didn't know the career existed until that senior year of college.
Okay.
And then, I pictured it as building fast boats, and really was following where there were research opportunities that led me into ocean renewable energy. And then when I was finishing up my master's at the University of New Hampshire, I was looking at options from electric boat, building submarines, to some cool advanced propulsion boats for defense applications. But then there's a mussel farmer from Maine who came to the university looking for help building a submersible mussel raft. So that opened my eyes to the world of aquaculture, growing food in the ocean. And that became another sector that I've invested heavily in my career, designing tools and engineering capabilities to design structures for growing mussels or oysters,
Sure.
seaweed, or finfish. And one of the surprising things for me in that project, so when I finished up my doctorate, part of it was actually building tools to figure out how these submersible mussel rafts are going to respond to waves and currents. And we actually got to put these tension measuring devices on the mooring lines on one of those rafts in Frenchman Bay off the coast of Maine, and measure the loads on those structures as it responded to the ocean conditions. And what I found out was that even our sort of best cutting edge tools for looking at how those systems work were pretty bad. And that opened my eyes to how much room for improvement there was in developing the tools to accurately and efficiently design these floating structures. And that's what my career has been built around since then.
And we'll get more into your career in a little bit. But I want to start with actually starting Kelson Marine. You started this company, if I remember right, in your basement. So what did those early days look like for you, and what kept you going? Because I'm sure a startup doesn't go smooth from beginning to end, and there's rough days. So what kept you going? How did you feel?
Yeah, good question. You're right. It started as a one-man operation in my basement. I founded the company in early 2020. So
COVID,
not intentionally coinciding with an international pandemic, but it worked out actually. There were some things that made it potentially even easier. Not the least of which was that everyone else was working from their basements too.
Right.
So when I would meet with clients, they weren't necessarily put off by the fact that I was just a guy with a computer working out of his basement. But we had challenges. We had some potential clients lined up who said, "Sorry, our investors are scared. There's a global pandemic. They're pulling out. This project isn't happening." So there were definitely challenges there. I was in a pretty fortunate position where once I started, I already had really good connections with people. And as soon as they knew that I was starting my own company, I had a lot of people said, "We want to work with you." So that I was really fortunate in that regard.
How many employees do you have now working for you?
Yeah, so we're a team of 8 full-time right now, with a healthy dose of interns and fellows working with us as well.
In the early days of the startup, was there a defining moment when you realized this could really become something special?
Good question. It was almost the inverse of that. I would say apprehension kind of grows with the number of employees that you're supporting. I think a few other startup leaders might resonate with this. Like, probably the coolest thing about what we do, and maybe the weightiest thing about what we do, is every time I hire someone, I'm saying, I can help you feed your family for the sustainable future. I'm giving you a long-term job. We're in it for the long haul. So that's a really rewarding thing to be able to do. And it also is what keeps me up at night. Are we doing something that's sustainable? Are we doing something where people are going to keep wanting to come to us and pay us to do the work that we do? So on one hand, even though there's a lot of risk at the very early stage of a startup, I'm not sure that those concerns ever go away. And if they do, I haven't quite gotten there yet.
Yeah. So I assume you believe right now today that what you're doing is sustainable. What makes you feel like it's sustainable?
Yeah. We need to use the oceans, and people are recognizing that. And the oceans are really tough to work with. They're unpredictable. Well, they are difficult to predict how these structures will behave. It's really easy to over-design or under-design these structures. And we are fairly unique in the world in what we can do to design these structures, whether it's farms or energy devices. So I think humans have a lot more potential for how we use the ocean, and that's a massive economy. Yeah. So I believe that every time we do a project, the amount that people end up paying us is a small fraction of what we can save them in the long run. So yeah, I do think it's sustainable.
Can you share some of the clients that you're working for? Is that possible?
Yeah, definitely. So we work across a number of sectors. Some of the clients that I can talk about, most of the clients we can talk about, we don't do much with defense or things that are top secret. We have a few more confidential projects, but some example long-term clients of ours have been a company called Ocean Rainforest that grows seaweed out of the Faroe Islands and has operations in the US and around the world. Every time they want to design a new structure, they come to us because we have this really unique skill set in designing aquaculture structures. On the renewable energy side, we're working with some pretty cool technology developers, including Qantas, Carnegie, Clean Energy out of Australia. People that come to us to solve some challenging problems around how their energy converters will behave in various ocean environments.
So how do you do all this with just 8 employees?
Yeah, so we have this mentality of extreme teamwork. One of the reasons ocean engineering has been a little bit inaccessible to these low margin sustainable companies that we try to work for is it's been very expensive, and it's historically been run as a little bit of a solo expert economy where you have experienced naval architects who kind of run their own system, or experienced ocean engineers who have their own way of doing things, their own set of spreadsheets, and they can solve their problems for $300 an hour or whatever. The way we've approached it is pretty different. So what I tell my employees is every time we solve a problem, we're building a tool. Every time that we write a script to evaluate how a wave energy converter is going to behave, we're building that onto our tool set so that every single teammate can use that when he or she is tackling their problem. So we call it this extreme teamwork method. Everything from our office layout to our file systems to our software repositories are built around this approach of every time we do a project, we're adding to our capabilities so we can do it better, faster, cheaper the next time.
Yeah. So you're learning off of your past experiences, whether they were positive or negative, you're learning from them. So a little bit ago, you talked about the unpredictability of the ocean, or difficult to predict the ocean. I would think that can create some financial and safety risks all by itself. Help us understand just how complex that challenge really is.
Yeah. So an anecdote which actually helped me feel a lot better about the complexity was I was talking with the ex-oil and gas executive, and they said for one of the largest oil and gas producers in the world, every time they build a new offshore platform, they build in a 400% margin of error on their cost.
Wow.
And that was validating for me because we're building the farms and trying to get down to like 15% and 50%. And that's a company that's built hundreds and hundreds of offshore platforms over the last 50 plus years. And they're still saying, we might be off by a factor of 4, depending on the project. And that's driven by a lot of things. Building anything is challenging, but the ocean is a little bit unique in that it can be incredibly different, even in small changes between one site or another. There's a tidal energy project up in Canada, not one of our clients, who put in a kind of like an underwater wind turbine. And within, I think, a month, they had lost all the blades of their turbine. And a year or two later, after they had finished the sort of the post-mortem on that, what they concluded was that they had measured the currents about 50 meters off of where they had actually put the turbine. And just the difference in current speeds in that 50 meters was enough to totally destroy their device. So that's something that's unique about the ocean that we don't encounter quite as much on land, is just how much variability there is, even across small changes in location.
Yeah. So let's take that a little further. So Kelson Marine uses dynamic simulation tools to predict real world ocean conditions. Help us understand really what that really looks like. Help our listeners and viewers.
Yeah. So I'll start with the sort of the on land analog to what we do.
Okay.
So when someone builds a bridge, they don't just build it and hope it holds up, right? They run a lot of computer simulations, a lot of finite element analysis tools is something most mechanical engineers are familiar with. Another class I took with my dad back in undergrad. And that's not easy, but it's very straightforward because those things are not moving very much. They deflect, just a tiny bit. We can do what we call linear mechanics. We understand the properties of steel pretty well. We've understood them pretty well for about 100 years. We've had computers doing these calculations for decades and decades, and we can run those analyses quite quickly. Once you get into the ocean, especially when we're dealing with flexible structures in the ocean, everything moves so much within a single wave period that you almost have to rewrite your equations for the forces and the motions in that structure at every single instant. And that's essentially what these computer tools that we use and develop are doing. They're sort of re-solving for those equations of motion at every instant. And those are the tools that I mentioned, when I first started using them, when I was working on my doctorate, and comparing them to what we were actually observing in the ocean. They can be pretty bad, pretty poor at predicting. And in some industries, like oil and gas or shipping, it's okay to have those large margins of error. They have the financial margins to just overbuild by 50 or 100%. But in these lower margin sustainable industries like ocean renewables and aquaculture, you don't have those profit margins to play with. So that's the impetus for developing precision tools so that we can actually help people figure out what's going to lead to something that's financially sustainable.
So listening to you, I feel like I'm taking a class from your dad because I'm learning. I don't know if I'm learning well enough, but I'm learning some things. So the projects that you work on, are you building platforms for people, or what are you working for your various clients?
Yeah, it's a range from project development to technology development. And if you go on our website, you can see a few videos or animations of some of the structures that we develop. So technology development means someone has a technology that they want to design and eventually sell to people, and we'll help them design that technology. It's usually in the earlier stages. We'll help them build, maybe a wave energy converter is usually in this category because that's not a very mature industry. Most of the technologies that we work with are in the early stages. They haven't really achieved long-term convergence on what the technology is going to look like. And on the other end of the spectrum, we have commercial projects that are project development. Someone knows we want to build a mussel farm. We're actually working on a permit for what would become the largest mussel farm in the United States by far for a client.
Okay.
So they know where they want to be. It's our job to help them design that farm of call a platform or a structure.
Yeah.
It's almost like a giant underwater clothesline that these mussels are grown from, hanging off of. And our job is to characterize the site, figure out what the 50-year worst case combinations of waves, winds, and currents are going to be. Design a structure that's going to perform well, that's going to grow the mussels well, be accessible for harvest and maintenance and things like that, and survive those conditions. And then we'll specify that in terms of engineering drawings that he can take to a marine contractor and say, deploy this for me. And then he can actually operate that project to and make a business out of it.
As I read about your business and you in preparation of today's podcast, I read somewhere that at the time of the writing that you're working with 8 different countries. Are you still with 8 countries? And if so, how does working with international organizations shape your business model and your leadership style?
Yeah. We're still in at least 8 different countries, not employees that we're all based here in Portland, Maine, but we have projects in 8 different countries. We may have added 1 or 2 since then. In terms of leadership style, it's always a good reminder about how communication works and how easy it is to think we're communicating clearly and realize there's room for ambiguity. So that helps me lead toward continual focus on not just how we are perceiving things ourselves, but how other people will perceive us. I guess other things we've picked up or that I've picked up working internationally is just the importance of being discoverable, making sure that our name is out there because we can't necessarily find the people in all these countries who need our skill sets. So we've put a decent amount of work into just making sure that if people are searching for someone with our unique skills, trying to make sure that they can find us. My oldest brother, Nathaniel, is another Cedarville grad, and he's got his own business down in Massachusetts, Orienteer Inc. He's a web developer, and he does our website. We've spent lots of time going back and forth about how he's helped build our website so that we can be discoverable from anywhere in the world.
Toby, I've enjoyed our conversation and learned a little bit about what you're doing. So you're roughly 6 years into your business, started in 2020, 26 now. When you look ahead the next 10 to 20 years, what excites you about what you're doing for people all over the globe?
Yeah, I really like the fact that we're helping feed and power the world, especially from a food perspective, the aquaculture work that we do, making sure that humans have enough sustainable nutrition is not going to be easy, I don't think, over the next decades. I think using the ocean well has a lot of potential to fill gaps that come from supply chain challenges and just the issues of having enough space and enough water to grow the food that humans need. So I'm particularly excited about that because we are really well positioned to help people design farms, design technologies that can be affordable and sustainable when it comes to feeding people.
Yeah.
On the energy side, we're doing some cool things, not all of which I can talk about, but using the ocean to extract both materials and energy. And doing, I say ocean engineering, we also apply it in freshwater applications as well. The floating solar world is an industry that's been taking off even in the US. And we've started to apply our skills to that sector. And that one is one that I think has a lot of room for growth in the US and abroad.
Are there other companies, I assume there are, doing what you're doing in the world? Is the competition fierce for you?
I would not say fierce. There's always competition in several different directions. We have about one competitor per country that's a lot like what we do. One in Canada, one in Norway, and a few others. And certainly we're competing with larger, more established engineering companies that at least would advertise that they can do what we do. So there's competition from every direction. That's definitely part of running a business.
But competition doesn't scare you. You embrace it, and it sharpens you, right?
I would like to think so. There's not really any alternative.
Yeah. Well, in this one story I mentioned a little bit ago that I read, you said that you've applied nearly everything that you learned at Cedarville. What stands out the most from your time as a Cedarville undergrad?
Man, I still draw free body diagrams every day. So this is another tribute to my dad. I took both statics and mechanics of materials with him. And Cedarville is really good at teaching the fundamentals. Not that it's not good at alternatives, but there's never enough time to learn everything about an industry in just 4 years or a lifetime. And Cedarville, I think, has really taken a stand on, we're going to teach people the how to understand the underlying principles, the underlying physics. And so in mechanical engineering, that means every time you start to analyze a system, you don't jump into the software, you don't start running it through a FEA tool. You start by looking at it, kind of isolating the sections that you're interested in and understanding what are the forces on that structure. Is it staying still? Is it accelerating?
Yeah.
In my world, I'm fortunate enough to work with systems that are always accelerating in one direction or another. But now when we work with these very complex floating arrays, I can look at them and I think back to nights spent in the basement of rock with friends trying to understand these concepts of free body diagrams and physics. And now I look at them and I can see the forces going this way through this mooring system and being shared across the array like this.
Yeah.
And that's just one example of something I learned early on, and again in my engineering courses at Cedarville, and still apply every day.
That's neat. It's neat to hear not just how Cedarville students / alumni are doing in their vocation and their profession. That's always exciting, but to really see the passion come from, like, when I'm watching you, that you really have a love for Cedarville because of what you're able to learn from your professors and your fellow students. So let me take the conversation in our final few minutes this direction. So you're someone who works at the intersection of innovation and creation, God's creation. How does your faith impact, influence how you do your job?
Yeah, so our core value at Kelson is to treat other people the way you'd want to be treated. That's written into our handbook. It's our one value that we communicate as a company, and it's one that we actually use to make decisions. So for our clients, it means we get things done on time. It means we tell it how it is. If the answer is, hey, your technology is never going to make you money, then we tell them that. And for our teammates, it means we are always willing to stop and ask questions. I think we have a really good culture of being willing, like genuinely willing to answer other people's questions without getting annoyed, without using that to judge the other person. It means we have a environment that's very flexible, very much accommodating to people's family needs or other needs for time off or accommodation. So yeah, that principle of treating other people the way we would want to be treated actually helps us make decisions for how we operate with clients and with each other.
Yeah. In addition to that, have you seen or do you recall experiences where your faith has anchored you during times of uncertainty?
I think I come back to this concept of stability. I'm part of a small business leaders group at my church, and we recently went through a book by called Gravitas, and one of the monastic principles in that that author highlights is stability. And I think we work in this ocean that's characterized by a lack of stability, and that
Right.
things are always moving. But stability isn't actually rigidity. Stability isn't being so solid that you don't move, that you never change your mind, that you're just convinced that the path you're on is the right path. Stability is actually the capability to be kind of knocked off course or out of position to a certain degree, and then come back to center. So when it comes to leading a business, I think that's something that that stability is ultimately rooted in my faith, and knowing that like wherever things go, like my life is not defined by how big of a company I can build. My life is not defined by how great of a house I can buy or maintain.
Yeah.
And that's helpful. We've had large projects cut in the last 16 months, several actually, things that were supposed to go through that didn't. We've had to find our feet again after thinking we had things really well lined up. But yeah, there's a certain stability that comes from knowing that our job is to do the work God has given us to do, and the results are up to Him.
Yeah, I think that's a very refreshing response, and truthful for sure. So I want to thank you for sharing that. And when I'm listening to you say that, I can just envision your dad saying the same thing. I can envision a lot of Cedarville, maybe all Cedarville faculty, saying the same thing. It's not about what we own, what we possess, how big we are. It's all about how we are willing to allow the Lord to use us in whatever way He does. Toby, thanks for joining me on the Cedarville Stories podcast. Let me close with one final question. If you could solve one major problem in the blue economy, whether that's aquaculture, renewable energy, or something else, what would it be?
I think what I most want to accomplish, and I think we're making really good strides toward this, is getting low trophic aquaculture economically viable in the Western world, including the US. So low trophic, that's seaweed, that's mussels, that's oysters. But right now, when you're trying to do it at large scales, doing it in a way that's financially sustainable is still a big question mark, especially in the US. But I think we can get there. Some of the tools we've been fortunate enough to develop over the last several years, some of the large research projects that we've done, we are unlocking the insights that can, I believe, make the difference between economic success and failure when it comes to producing food from the ocean. I think we're getting there, and I'm excited to continue to close that gap.
So you think you're getting there and you're closing the gap. How long do you think that gap is closed to a good percentage?
Yeah, good question. I had a really encouraging experience this winter. So I mentioned earlier in this podcast that what got me into the aquaculture side of ocean engineering was a mussel farmer in Maine,
right,
back in 2013, coming to us and having me help him design his submersible mussel raft. He came down to Portland this winter with a bag of smoked mussels from those rafts. He said, he's continued to work on that technology for the last, 10 years now. And he said, he was all excited. He's like, Toby, I'm finally making money from mussels. But this is turning a profit for the first time after farming for decades. And I'm going to be able to retire now. And that was super validating. One, the mussels tasted good. I enjoyed that. But two, to see that project from 10 years ago, really, continue to come to fruition and get someone excited about the fact that they can not only feed people, but make a living doing it. I think that even though it took 10 years and it may take us another decade to realize, commercial scale ocean aquaculture in the US, I think we'll get there.
That's great. Toby, I've enjoyed learning a little bit from you, hearing your story, and I wish you the best as you continue to push forward, especially in that aquaculture space and making food more available to people all over the world. So you're doing a great work. You're a great representation of Cedarville University and your parents. And thanks again for joining me this week on the Cedarville Stories Podcast. Thank you for listening to the Cedarville Stories Podcast, brought to you by Cedarville University. To learn more about Cedarville, visit our website at cedarville.edu or click on the link below in the show notes. Be sure to come back next week when we'll share another Cedarville story for God's glory.